My name is Stephen Estrella. I'm from Freedom Photonics. I am the Quantum Technology and Applications Technical Leader. And today I'll be talking about some of our technology that we've been developing specifically for quantum applications. Just to give you a quick overview, we're a small business in Santa Barbara, California, and we are a unique and innovative manufacturer of photonic components and modules and subsystems. And we're addressing everything from chips all the way up to subsystems. And given our broad capabilities, we can provide a lot of these things, and that makes us very unique, being the size that we are. And we also work in a variety of material platforms, particularly in group 3-5. This would be indium phosphide and gallium arsenide. We also work in group 4 materials. This would also include silicon photonics and the hybrid integrated solutions thereof. And while most of our traditional product offerings have been more in the classical space, we have many ongoing projects, specifically in the quantum sensing, communication, and networking areas. And just to give you an example of what we have been doing for the many years that we've been in business, there are some examples here shown below, going from chips on the left all the way up to modules on the right. And although we may be a small company, our core expertise spans all areas. An example is kind of shown here. We go all the way from design and fabrication to test and packaging, and even manufacturing and subsystems. We have over 21,000 square feet of our facilities and multiple 10,000 class 10,000 clean rooms where we house all of this fine equipment. And of course, none of this will be possible without having an excellent team. We have over 50 employees with deep know-how and expertise that produce all of these great products for us. So in terms of products, we have many off-the-shelf components. These would be primarily in the areas of tunable lasers. We have centers from 1250 all the way up to 1750 nanometers. We also offer high-power DFB lasers at 1280 and 1550 nanometers. These have greater than 400 milliwatt output power, less than 300 kilohertz line width, and also record high wall plug efficiency. We can also produce single spatial mode lasers exceeding 1 watt, and some of those are kind of shown on the bottom left. And in terms of private label products, we have done this for a variety of different customers, all the way from custom lasers to photonic integrated circuits, and also advanced micro-optic solutions. And some of those are shown here on the bottom right. So specifically into the areas of atomic sensing, we are active in producing lasers at around the 7xx or 8xx nanometer range, particularly for rubidium and cesium. Some of these lines have already been discussed. But here I'm showing a specific example of our 780 and 795 nanometer DFB laser technology. These have integrated semiconductor optical amplifiers, and we've demonstrated mode hop free tuning here in this case over a 50°C temperature range for various laser and amplifier operating points. It's worth mentioning this kind of performance is rather difficult to achieve, but it speaks to our expertise in laser design, fabrication, and packaging. And lastly, I'll just touch on that we also provide control electronics. These include low noise drivers, temperature control, active wavelength locking, and we've even produced very compact modules where we've co-packaged photonic devices, micro optics, and even the laser control electronics all within a package about the size of the quarter, and that's shown up here on the right. So as you can really see, we fulfill the full entire range of photonic development, all the way from chips all the way up to very advanced modules, and we're quite proud of the work that we've done there. And so I would just say thank you for listening, and feel free to either visit the website or contact us directly and see how we can help you.
No, this presentation was, in this webinar is focused a lot on, basically focused on the lasers enabling quantum, but right with the laser, and you guys are sort of known for doing photonic integrated circuits, right?
Correct.
Yeah, and that's sort of, well, I'm just saying it's sort of part and parcel. I'm hearing constantly on the, developing the laser prioritization tool that, so many of these quantum applications need the laser, but they also need the PIC, right?
Right.
And so, the question I had for you on the PICs is what type of PIC optical functions do you provide today?
So we have a variety of active platforms. And what I really touched on today were mainly sort of specific to lasers, but I also touched previously, if I go back a little bit, to some of our existing DFB lasers that also integrate optical amplifiers. Now, power is obviously a concern, and so is stability. But we also can use these as a shutter or as a variable optical attenuator, and these can be operated quite fast. So not only do we have the ability to amplify the light, but obviously we can extinguish it, turn it off. And those are very basic functions. But we do have other platforms where we've integrated modulators, for instance, and also sort of integrated detectors. I haven't showed any of that here, but we have done plenty of that work sort of in the past.
Right, and I think it's extremely important for the audience here because you supply lasers like DFB lasers, et cetera, but you also supply the PIC and the semiconductor optical amplifier all in the same little package.
Correct, and not just in the same package, but in this case, in this example, this is this is a photonic integrated circuit. And so if you could zoom in basically to that package that's kind of shown up here in the upper right-hand corner, you would see that it's just sort of the basics of temperature control and lensing for getting light in and out. But all the key functionality is really contained within one PIC.
Awesome. So this is a very open-ended question, but so let's say you're a quantum solutions company and you need a laser source and a PIC or semiconductor amplifier and a laser source. What sort of commercial step what kind of threshold needs to be beaten so that so Freedom Photonics would take something like that on, right? To justify a purpose-built PIC or a purpose-built laser with a semiconductor optical amplifier, for example. What could you say around those lines?
Well, I think more importantly, sort of just developing sort of the enabling platform. And so already we've kind of done that here for, say, 780, but this is easily tailored to other wavelengths that are even close by, sort of maybe around 850 or such. And so really for us, I believe, the need has to be there, obviously.
Right.
But we have, the deep expertise and know-how to do the photonic integrated circuits. And we routinely do this even at 1550. So really, we're taking advantage of our sort of expertise and track record addressing sort of the larger markets within sort of datacom and communications and such. And we're applying those same principles to address devices that are more required for quantum. But obviously that is a jump, and the market pull has to also be there. But we're ready to do that when there is the correct need to do so. So if you have a need, then we love to chat.
Great, thank you so much, Stephen. That was very helpful.